Okay, so we have the problem, the question of Ricardian equivalence here. So we have rich and poor consumers. They both make it easy, so rich and poor, they both have the same income, they have the same amount of taxes, and they both have the same initial wealth. So, I mean, one's not rich or poor in terms of income or wealth, but we're going to say maybe richer and poor in terms of access to financial markets. Right? So maybe someone comes from a family that's very well connected, and the banks will give them any access to credit, and the other person doesn't come from that family, doesn't have access to financial markets, but they have the same income otherwise. Yeah? This makes the problem a little more straightforward. Right, so our poor consumers, they're credit constrained or poor in the sense that they would like to borrow in period one, but have no access to credit markets or banks. Yeah? The budget constraint is then given by their income in period one and period two. Our unconstrained consumers have the intertemporal budget constraint, so it's just like we had in the previous problem. We have a present value of consumption, and then our present value of net income plus initial wealth. All right, both types of consumers maximize their lifetime utility. We have the log assumption, and we have this beta plus R equals 1. Okay, derive the optimal consumption decision for constrained and unconstrained consumers. Okay, so our constrained consumer would like to borrow, it's in the problem statement, but can't. Yeah? Which means we're already done. For the constrained household. Its consumption, right, it can't optimize. It can't switch and move income across periods. It doesn't have access to savings, to credit markets, or to borrowing. We assume it would want to borrow. Right? So it essentially has C1P is equal to V1 plus Y1 minus P1, and C2P is then equal to Y2 minus P2. So our household that doesn't have access to credit markets consumes its income in each period. Right? It would like to borrow is in the problem statement, but it cannot. Now, the resource constraint says less than or equal to. Right? So this is also something to think about why we do this. And a lot of problems, even though we know, we kind of know the answer. Let me slow that. So if our consumption here is less than our present income for our poor household, what does that mean? What are they doing with the rest of their income? They would be wasting it, right? And we discovered yesterday, we talked about, right? We're not going to waste households because we have our utility function, right? That utility function is positive first derivatives. So they could waste, but they're not going to. The reason why we write budget constraints often like this is to make clear what is income, what is expenditure, which side is which. If it's an equality, like in here we have names that make sense, income and consumption, so you know what is the income, what is the expenditure, just by the names. But sometimes in problems they're a little more complicated, or it's left implicit, or it's not so clear, perhaps just by the terminology. And so using this less than or equal tells you what the positive things on the less than side would be expenditures, and the positive things on the other side would be the income, right? Because you can always choose, theoretically, right, before we look at the utility function, it wouldn't be optimal, but the household can choose to consume less than its income. It can choose to just waste, right? But it can't choose the other way around. We can't choose to have more consumption than we can afford. right? So that's why it's important. It tells us which is the income, which is the expenditure side. You can always spend less than you earn, but unless you have access to financial markets, you can't spend more than you earn, right? So that's why these inequalities are usually or often written as. Right? But so for our poor household, they would like to borrow what they cannot, so they can only consume up to their present income in each year. All right. Now for our unconstrained households, it's different. We have you wrote the Lagrangian, they have their lifetime utility, and we have their lifetime budget constraint. Okay, take the derivatives of the Lagrangian with respect to C1 and C2, we put it together, and we get the Euler equation that we've seen a couple times now. We also saw yesterday, of course. All right. Now remember, we also have the condition that so C2R C2R equals C1R. The product of those two were equal to 1 in the problem statement. Right, that doesn't actually, it probably doesn't show up until it's total. We haven't made that assumption yet. I'm sorry. You're right. So up to this point.
We have
Other problem should have, that's right from the beginning. So we can assume it right from the beginning. So it's okay. I mean, this isn't wrong. It's right. We can just go a step further and recognize that the product of those two is important, right? Okay. But right, so obviously then from B, okay, now so you put this in here, we can make it a little simple. It doesn't matter because here, right? Then here you inserted it. So this is correct. This is correct. If you inserted it before, maybe you just save a little bit of ink, right? But that's it. Right? That's not. It's correct, right? All right, and then we get we put it together. We have the expression we have here, right? And again, with the budget constraint, we're going to always go up to equality, because if we don't, then we're wasting, right? But so it's that this is still true. It's less than or equal to. It's just simply right, equal to. And equal to is also less than or equal to. So it's not wrong, right? It's but I would just make it clear, right, like this. Okay. And fine, so now, right, and here you obviously, despite what you did here, you of course recognize that and put it into here, right? So I guess so the answer that I would have put here would maybe I would just put a verbal statement. So I would have written something like constrained household is assumed, that's in the problem statement, to want to borrow in period 1 but it is credit constrained and cannot. Thus, its consumption is equal to its net taxes and wealth income in each period. Which is what comes out here, but why we can just skip all this and just write that directly. Okay, so we take this, put it in here, and we take this and put it in here. Okay, because our aggregate consumption function, we have a share of poor households and a share of wealthy households. Right, and now if we take the derivative with respect to this current disposable income, which is initial wealth plus this after-tax income. Then we get, so the derivative of C1 with respect to this whole term is then equal to mu plus, there's that whole term again. So it's plus this term out in front. All right, and then we can now start to think about what this means, particularly we start comparing with the case of mu equals 0. Yeah, so mu equals 0. That means we have no credit-constrained households. We have a marginal propensity to consume of 1 plus R over 2 plus R. That's less than 1. Right. How about the other extreme? What if we have only credit-constrained households? Right, so what if mu is equal to 1 when this all disappears, and our marginal propensity to consume is equal to 1? So this means we have the high as our share of credit-constrained households grows, our marginal propensity to consume grows as well. Right, you could also think of then taking the derivative of this with respect to mu. Right, and if you did that, you would get then 1 minus 1 plus R, 2 plus R. Or 1 over 1 plus R, or 1 over 1 over 2 plus R, which is greater than 0. So marginal propensity to consume is increasing in the share of credit-constrained households that we have. I mean, and think what this means essentially is that if we have non-credit-constrained households, they're going to smooth. So if you give them more, if they have, for whatever reason, more income today, they're going to consume part of it and save part of it. Right? So they're not going to consume all of it. Our credit-constrained households, however, consume all of their income, the current income. So if they have more current income, they're going to consume that additional unit. The marginal propensity to consume is equal to 1. So it's going to be increasing in mu. Okay. right? And so, we can work through this. So that's one of the ways that I would interpret it. And we get to this answer here, which you can write then from above, so this is less than 1. Okay, now you'll look at this. So the difference between the aggregate marginal propensity to consume and the marginal propensity to consume of a wealthy household. Right? Wealthy households is greater than 0. All right, so this means the marginal propensity to consume on the aggregate is greater than the case of when everybody is unconstrained. Right? So it's a similar argumentation of what I'm doing here. Right? It's done differently. Okay? So what you're trying to say is that if we have credit constraint and non-credit constraint, the marginal propensity to consume will be greater than if everyone is not credit constrained. Right? Okay? And then you go a step further and say then that also the constrained, so that's what you have here. So constrained, or this is the should be call it aggregate with constraint, right? Because it's not only the constraint that would be here, that would be just 1, but you compare the aggregate with constraint and unconstrained. So, the explanation here we have the economy has credit constrained households with an increase in disposable income, poor people, have a higher marginal propensity to consume than rich people who will spend a higher fraction of their household income. Right? Perfect. So I would have argued maybe with the derivative of the marginal propensity to consume, or compared mu equals 1 and mu equals 0. You built a difference between the aggregate and the mu equals 0 case, right, and showed that it's positive. Right? Just as good. Different way. Just as good. Okay, now we want to address the required equivalence. So we want to think about there being tax to debt financing. So we want to change our taxes in period 1. We can think of maybe decreasing taxes by 1 unit in period 1, and then borrowing, the government borrows to finance that, and so then has to pay this back by increasing taxes in period 2. So it has to pay back an amount of taxes in period 2 that's equal to the change in that tax period 1, the opposite direction, the opposite sign. So it's a tax increase, here a tax decrease, plus the interest they have to pay on the debt financing of that tax break. Okay. So the way so the answer is correct. You say that the required equivalence holds, consumption path is not affected. Right, with no credit constrained consumers. Why? Or can we show that? Would be my question. So what we can do go over here, but I'm going to go back and forth to kind of see. I want to look at the change and see what are. And I'm going to, the only things I want to change Alright, so this is the way we can do the holding everything else constant. First I'm going to take the total derivative of C1R here. C1R. Equals, plus 2 minus D2 R. But now I want to assume, and we're going to hold everything constant. We're only going to change the taxes for now. So this gives us then minus up front, 1 plus R, over 2 plus R, dt1, plus dt2 over 1 plus R. And as you showed here,
T2 equal to 1.
those terms are going to cancel out. Above this is equal to 0. So there's no change in our household consumption. Right, we could also, this isn't the case where we have no credit constrained consumers. It's also interesting that let's look at the case of our aggregate consumption. Where we have credit constrained consumers. So we just showed that this is equal to 0. So this will be equal to mu times dC1P. And if we take the derivative of this with respect to T1, so if we only change T1, this is going to be equal to mu times minus dt1. And it's simply because for households have an MPC, marginal quantity consumed, of 1. Alright, so the tax cut. So dt minus 1 is negative, and minus dt1 is positive. This will increase the poor household's income and hence their consumption because the MPC of 1 for 1. Going to share mu. Right, and this will then be greater than 0. Now, so there's no effect if we have households, we have no households who are credit constrained. But if we do have credit constrained households, then there's going to be an effect, and this debt financing taxes would increase aggregate consumption. Okay. Now let's consider temporary tax cut by 1 unit in period 1 that is financed through cutting public consumption in period 1, such that the intertemporal government budget constraint holds. Okay. So we need to think about what's an intertemporal government budget constraint going to look like here. Alright, so we have government as consumption, public investment. I would write this over a couple, two periods just to show what happens. So our government beginning period, GT, has to pay back or roll over its debt in the previous period. Government assumption. Debt is equal to taxes today plus new debt. Right, okay. And so what we have in this case is we're going to change taxes and government spending by the exact same amount. Actually, another way that you can how you can get to the relationships that we had over there from this government budget constraint is to write this for the next period. And then substitute that in there. And we would then get GT plus GT plus 1 over 1 plus R. Is equal to TT plus T plus 1 plus R plus T plus 1 plus R. Right, so we have this sort of present discounted value of income, present discounted value of expenses of the government. And this is how we had before dt1 has to be equal to the negative of dt1 with this interest component. That would be changing dtt and dtt plus 1 such that the budget constraint, nothing else changes the budget constraint. So D would be, we would have, holding everything else constant, we would need D equals dtt plus B T plus 1 plus R for the government budget constraint to hold intertemporally, and that's then exactly what you wrote over there. All right, so for E, what we have now change in government expenditure is equal to change in tax expenditure. All right, well now things are going to look a little bit different. Now, we don't have to raise taxes in the future to pay for this government or the tax cut. We're paying for the tax cut by reducing government spending. Right, so now we would have then the C1R. Go for this here, it's going to be equal to minus 1 plus R, 2 plus R, dt1. It's not going to be equal to 0 anymore. positive because it's a tax cut. dt minus 1 is negative, a tax cut. All right, for our poor households, that stays the same. So for our aggregate consumption, we get then here, it's mu plus 1 minus mu, 1 plus r, 2 plus r, minus times minus d1. Now if we have no credit constrained consumers, right, the whole comparison is simply then the same as the comparison here. It all comes down to this, how does NPC changes. Now that we have their two effects. Right. Why is E different than D? One is debt financed, we're going to pay it back in the future with taxes. And the other one is a reduction in government consumption. So what ends up happening here, we have an increase in private consumption. Essentially the government is reducing its consumption, making itself smaller, and this gives more room to private consumption. Right, but it's still, right, you can think of this NPC is less than 1, if we show it here, which means that for each reduction in government spending, the increase in private consumption is less than 1 for 1. Right, so we have a think again on this idea of the multiplier.
Professor,
Yeah.
want to erase the text, the last sentence after the
Yes.
C1 private increase. After C1, no, after C1 private increase from the same ratio, yeah, to the end, yeah.
Right, but even so, if you think about it, so I think it's not entirely correct. I don't think this part got lost, but you saw the right intuition, right? And this result came out through there. So, okay. What do we want to do? Kind of took it slow with the problem sets. Is it okay if we just start the next lecture and then stop a little bit before 12, or do we want to take a break now and then a lunch break in 20 minutes after that? Okay.
Cái giờ ý là bây giờ mình nghỉ sớm đi, xong 1 giờ cái mới là 12 rưỡi mình bây giờ xuống ăn thôi và cũng có đỡ hàng.
Yeah, you want to continue?
Yeah, let's just continue. I think that makes sense.
Ý là học xong em cái giờ trưa mình xuống sớm.
Ý là giờ xuống luôn nè. Là mình đi mình
Okay.
no sorry. I think that we can stop now and we turn it back like earlier, maybe 12.
So to do lunch now a little bit earlier.
Yeah.
Okay.
Then 1 hour.
Yeah, we can do
after
that.
1
We can do
hour.
that.
Yeah.
Okay. Was the person that we were going to meet for lunch, then we'll meet them later, or I just remember that she said that for someone from next year's cohort.
Ý là sợ chị khi ra
Okay.
ngoài giao
So then let's take a break.
tại
Ý
vì
là em cũng